A really cool number in mathematics is the number e. E actually has a really interesting history. John Napier, Jacob Bernoulli, and Leonard Euler are all kind of given credit for the number e, but Euler is actually the one who used a letter to represent the number first in a letter. So some say E comes because of his last name, Euler, which starts with an E. But some others say that he had already used the letter A for another number, and E was the next vowel. So kind of a little bit of an interesting history there of why it's called E. And what is E? So E is the limit as n goes to infinity of 1 plus 1 over n to the nth power. Now this number is irrational, like pi, which means that it's a decimal that never repeats and goes on forever. The approximation of E to the 10th power is 2.7. However, if you have a calculator that has the number E, it will have been programmed using the limit, so it will be the correct. It won't be the rounded version. Anytime you use a calculator that has E programmed in it, you want to use the E. You do not put 2.7. You put the E, which we'll discuss in problems in a little bit. Now, the function y is equal e to the x is called the natural exponential function. And E is going to be the most convenient base to use in calculus. So there are some really cool things on the internet that talks about E, the history of E. So even if maybe you're not into mathematics, the history behind this number is really interesting. So you can Google it and find some things about it. So let's take a look at this example. So Lydia is the manager of a company that manufactures small appliances. She determines that X units of a particular appliance will be produced and sold at a price of P dollars per unit. All right, so P is in dollars. X is the units, where P of X is equal to in the following price function. How much revenue should she expect when 100 units of the appliance are produced? Okay, so we need to remember from the previous section that revenue is equal to X times P of X, the numbers, times the amount you're selling each for. So that's going to be X 200 E to the negative 0.01X. So this is my revenue function, but specifically here, they're asking for how much revenue for 100 units, right? So I knew to create my revenue function because it said how much revenue, and it specifically asked 100 units, and X represents the amount of units. So I have R of 100 is equal to 100 times 200 E to the, and I'm going to do this so that I can talk about the calculator here. I'm going to put the number here in parentheses, the power. So when you are putting this in your calculator, put the power itself in parentheses, all right? So that it reads as negative 0.01 times 100 as the power together. And so if you do this, make sure you check it out. It will give you, and this is money, and money always gets rounded to the nearest hundredth. Her revenue is going to be $7,357.59. So always remember money, right? 2 decimal places. Okay, let's take a look at another one. Same problem, different question asked. How many units is she selling if her appliance is priced at $150? So they're telling you that it's priced at $150 and they're asking you how many units. So now what we're doing is we're looking for X, and we're given that P of X is $150. So we're not talking revenue anymore. We're back to the price function. So we know the price is $150 and we're looking for X. Okay, so if it's been a while since you've taken algebra, what you do first is you isolate the E part, the exponential part. So we're going to divide by 200. And that's going to give us 0.75, 150 divided by 200, and then E negative 0.01x. And now what we do is we need to do the inverse of e to be able to get rid of it. And the inverse of e is called the ln of x. So if you have y is equal to e to the x, then its inverse is y is ln of x. So a good example is like x cubed. The inverse of x cubed is the cube root. So if you have x cubed is equal to 8, to undo the x cubed, you cube root it. So here, to undo the e, you ln. So you have to do it to both sides. So you have the ln of 0.75 is equal to the ln of e, negative 0.01x. But because they're inverses, the ln and the e cancel each other out. So I have ln of 0.75 is equal to negative 0.01x. And then I divide by negative 0.01. And that's going to give me that x is approximately 29 units. Now, remember that they're asking how many units, and because it's, right, we were talking about small appliances, you can't have partial appliances. So you have to round it to the nearest whole number. This is what's important when you're doing a word problem. Make sure that your answer makes sense in context of what the problem is asking. All right. So one of the very common things that E is used for, which is more attributed actually to the second gentleman that I mentioned at the beginning, Jacob Bernoulli, is E represents when you're compounding continuously. Now, what does that mean? So first, let me begin by using kind of the business application of compounding continuously. So suppose you have a principal P. So principal P means is what is the original amount. Okay, so principal original amount is invested at an annual interest rate R. So R for rate. So that's kind of easier to remember. For T years. So T is in years, right, for this formula. And interest is compounded M times. So let's, right, we have quite a lot of letters here. We have the principal P. We have the rate R. We have T is in years. Lots of colors. We're compounded M times per year, which I'm going to discuss. And then the last thing is that the future value A. So that's what that's the amount you're going to have in the future. So 5 letters. And the formula is the future value. So the future amount is going to equal to the original amount times 1 plus the rate divided by how many times you compound per year raised to the MT. Now, if you're compounding continuously, all right, so if the interest is being applied on your value of your account all the time, then the future value is given by A is equal to PERT. This means that M is no longer in effect. E replaces the M, and the reason for that is because as M goes to infinity, you're now applying the value of E, right? So it is the same, right? I mean, if you take the limit as n goes to infinity, you can see, let me rewrite E here. Right, so it's not a coincidence that the m is at the bottom here and the m is here, right? So in this situation, the m is representing the n. So if you're compounding continuously, the m part gets replaced with the e. So the parentheses gets replaced with the e and then the RT. Let's apply it. And if maybe you're confused about what the compounding part means, this application will probably help you. So what amount will be in an account after 5 years if $100 is invested at an annual nominal rate of 8%, compounded, and it's asking me 5 different. Compounded annually, semi-annually, monthly, daily, continuously. So for these 5 here, I have to use the first formula. And for this one, I have to use the second formula. So continuously gets its own formula. So what does annually mean? So first, let's write out all of our goodies before I start that. So 5 years is going to represent the T. So T is 5 years. $100 is invested is your principal amount, your original amount. And the annual nominal rate, the interest rate, is 8%. Now remember that you can't put percentage into a formula, so you have to divide it by 100, change it to decimal, which is 0.08. Okay, so annually means that you are compounding. So M stands for how many times you compound per year. So if you do it annually, that's 1 time per year. So annually is M equals 1. If you do it semi-annually, you compound twice. Semi means 2 times a year. Monthly, well, there are 12 months in a year, so if you do it monthly, it will be 12. 12 is probably the one that you're most commonly used to. For example, if you have a credit card, they compound your interest on your credit card monthly, once per month. All right. Daily, well, how many days is there in a year? 365. And continuously means that M is going to infinity, and we're going to use the other formula. So then we start to put everything in there. So A is equal to, let's look at it. We're going to have it right up here. 100, 1 plus R is 0.08 over 1 times 1 times 5. Then for the other one, A is equal to 100, 1 plus 0.08 over 2 times 2 times 5. Then A is equal to 100, 1 plus 0.08 divided by 12 times 12 times 5. And then A is equal to 100, 1 plus 0.08 over 365, 365 times 5. And last but not least, in the other one, I use the other formula, so there is no M because I'm compounding continuously. So it's going to be 100 E, the R, times the T. Now, the key here is to properly enter this in your calculator, so parentheses. And it goes with the same thing I was telling you in the question above. Use parentheses for the power also. So this one is going to give you $146.93. This one is going to give you $148.02. Round to the nearest hundredth. We talked about that. And monthly is going to give you $148.98. Daily is going to give you $9.17. And last but not least, continuously will give you $149.18. So the more you compound interest, because the interest is being applied more times, the more money you will have. So this is why, if you take a look at the numbers now, all 5 of them in a row, they're increasing, right? Because the more we're compounding more each time, so the amount in the account is going to be more each time. These numbers should be close together. That's one way of knowing that something is going right. If they're apart, either the formula might be incorrect or your calculator work might be incorrect. So double check both of these.